Alright, Crewton Ramone's House of Math. Turn off the fan, it's hot today. Here we go. Very quickly, doing this problem in terms of Mortensen math. And what are the terms that we're going to talk about? We're going to talk about same as. One thing in terms of another, same as. We're going to talk about the rectangle, a particular kind of rectangle, the square. That one right there, x squared, 2x, well, x squared, 2xy's, and a y squared, or in this case, this could be an a squared, 2ab's, and a b squared, and when I look at that, you can see that it's a plus b squared. It's just a plus b. If we call this an a square and this a b square, and these are ab's. And see, if you played with blocks, this is crackers and easy stuff. Alright, so the question was, how do I express the hypotenuse in terms of the perimeter? Right? What we're saying is same. The hypotenuse is the same thing as the perimeter. How do I make that? How do I write that in algebraically? Okay, the information we were given was A is the area of this triangle is 25 centimeters squared, so that means that A times B is 50, of course, because 1/2 base times height would be 50 divided by 2, which would give us the 25, right? That's just basic math right there. It's a formula you should know. To find the area of a triangle, I take half the base times the height. And then over here, like I said, the h equals the square root of a squared plus b squared. Well, of course it does, right? The same thing. And I want to know about h. This is the whole thing is talking about h. I don't want to know about h squared, and I don't want to know, right? I want to know about 1. I want no fun, get back to 1. I want to know about one thing. Right? If I don't want to know about the square root of x. I don't want to know about 2x or 5x. I just want to know about x. When I'm talking about algebra, when I'm in this problem, if I want to know about the hypotenuse, I want to know about one hypotenuse, just the hypotenuse, not the hypotenuse squared or whatever. But in order to get there, in order to get down here, we have to do all this other fun stuff. Okay, so I should know that a squared plus b squared equals c squared. And again, same, knowing that c is the same thing as h. Right? The concept of same. Right? There's only 5 concepts. Go to my website and you'll see 5 concepts. People just don't know how to apply them. Okay, so these things are non-different from each other. All of this, right? H squared is the same thing as a squared plus b squared because all I did was substitute h in for c. Right, because c is the hypotenuse, so I'm going to call instead of calling it c, I'm going to call it h. What's the big deal? Alright, so, and if I know this, then I know that. Right? I mean, it should be fairly simple. Okay, but that's where that comes from. They were trying to help you by giving you extra information, and instead it winds up scaring the kids. Alright, so, but don't be scared. So now I'm going to take my h squared, I'm going to add 2ab. Again, why am I going to do that? I'm going to do that because I like that. I like that. I like squares. Squares make things easy. Okay, so my a squared plus 2ab plus b squared, that's what it boils down to in a simpler form. So I have the concept of the rectangle again, and not just any kind of rectangle, a square. Right? Concept number 3 being used there. Okay, now I have to substitute same, going back to the concept of same. I don't like this anymore. I don't want AB because I'm trying to get things in terms of H and P. So I need to get rid of all my A's and B's. And the way I do that is I start putting numbers in where I can, or putting P's and H's in where I can. That's the reasoning and thinking behind it. How did I get P minus H? Again, perimeter is just A plus B plus C in a triangle. We know that. And there's our buddy H, and I could change that H. I should have put the H in blue. I should do that. Let's do that real quick, just for fun. We'll put the H in blue so it's absolutely clear that all we did was make that, right? And then look, that's all it is. We'll put the H in blue every time we see it, right? Because that's what we're looking for. We're trying to get the whole thing in terms of H. Okay, we don't like C anymore. We want to know about H. Okay, so I did this. How did I do that? Here is 0. Pretty simple, right? Stuff that's same on both sides. Again, when we talk about problem solving, same over here and same over here. If I subtract h over here, right, I get 0. I'm not even going to write it. Over here, I get my negative h. Okay, so now I know that this and this are same. So I can put it in here. Pretty simple. Okay, but it's not, I mean, like when somebody shows you it's easy, but you have to do this reasoning for yourself later on in different problems. Okay, so again, you'll see the big HZ over there. Hero 0, what do I do? Because now I have H, right? So I'm just going to, stuff that's same on both sides, I'm going to get rid of it using Hero 0. I'm going to add negative H squared to both sides, basically is what we're going to do. Okay, so then I just wind up with this. Now everybody's got, all I got is P's and H's. We like it. So now if all I have is P's and H's, then all I just got to do is solve for H. I could try and solve for P, but solving for P doesn't work. First off, that wasn't the question, but the point here, I just put that in there very quickly, is because I have P on both sides and we don't like that. And I want to have it in one thing in terms of another thing, and it's like defining a word by using the word. You can't do that in English, and you can't do it in math either. Well, you can, but it's frowned upon. Okay, so here I have 100 is the same thing as P squared minus 2HP. What do? Hero 0! Got rid of that, right? By just adding 2HP to both sides. Simple. Simple. Follow me? Easy, right? So I got a 0 here. There's actually a 0 hiding over here, which is 2HP minus 2HP. But why would I write all that? It's just 0. So I'm not even going to write it. Nothing. There was a big argument. Why do you need a symbol if it doesn't stand for anything? Anyway, okay, so there's nothing there. And now I have 2HP there. Okay, so now I can just, again, go the other way, get rid of the 100. Why am I going to get rid of the 100? Right? It's not going to walk across the equal sign and become 0. I'm going to add a negative 100 to both sides. Right? And what I have over here basically is Hero 0, if you look at it that way. I have a Hero 0 over here, which is a 100 minus 100. And when I take away the stuff that's same, which is the 200s, right? I'm left with a negative 100. However you want to explain that, but do not explain it where you have 100 crossing the equal sign and it becomes negative, because it's exactly not what's happening. The concept is same and Hero 0, and what we have there is that what you're doing is taking away same stuff on both sides. It's consistent all the way through. Taking away same stuff on both sides. It's consistent all the way through. Hero 0. Okay, now no fun, get back to 1. I don't want to know about 2HP. I want to know about H. How do I do that? I divide out, right? And that's the no fun, get back to 1. I divide out 2P from both sides. Right? So I just divide this by 2P, and I divide everybody else by 2P. And I can use economy of symbol, excuse me, I can use economy of symbol to give me H equals P squared minus 100 over 2P, or I can leave it like that. Sometimes on tests, if you have standardized tests where you have multiple choice, you'll see one or the other, right? So you need to understand that this and this, once again, are exactly the same thing. This is the concept that we're driving home here. And what we've done is put everything in terms of H. H is this. H is this. The perimeter, if I know the perimeter, I know H. If I know H, I know the perimeter. That's it. That's all we're doing. Logic and reasoning using 5 basic concepts. And they're labeled here where we use them. Same, Hero 0, no fun, get back to 1, Hero 0, concept of same, being able to substitute one thing for another and do math. And be able to get rid of the variables we don't want and keep the variables that we do want. That's what we're doing here. Okay. So, CrewtonRamonesHouseOfMath.com for more.